Okay, so we have another problem here, and this one actually comes from a book called Conquering the Physics GRE, which is essentially a big test for grad school in physics. And it has a whole bunch of different sections. This is the first section, Classical Mechanics. So I'm going to try to go through some of them and hopefully get better at it. So the first one is a block of mass 5 kilograms is positioned on an inclined plane at an angle 45 degrees. A force of 10 Newton is applied to the block parallel to the ground. If the coefficient of kinetic friction is 0.5, which of the following is the closest acceleration of the block? Assume no static friction. Well, you might get an idea looking at this. We don't know if the block's going to go up or if it's going to go down. We can see the options have up the ramp, down the ramp, everything in between. So I guess the first thing I would ask myself is up or down? And the way that we're going to do that is we're going to, in part, put together the free body diagram of the block. So we're going to tilt it, of course. This will be my x-axis. This will be my y-axis. We have normal. We know we have our force due to gravity, our weight force. We have a force being applied. Now, there's also, we know that there's kinetic friction. So we know that the block is moving. The question is, which way? And that's going to be important because if it's moving up the ramp, you're going to have friction pointing this way. And if it's moving down the ramp, you're going to have friction pointing this way. Just by nature of it opposing the direction of motion. So, just going to sip of water here. So we have this incomplete free body diagram. And what we want to see is F is F less than, in this case, this component, mg sine of theta. Well, we know g is 9.81, and sine of 45 is root 2 over 2. That's going to be something bigger than your, I'll even plug it in here if I can find my calculator. What was the mass? The mass was 5 times 9.81 times root 2. You can kind of tell that 5 times 9.81, it ends up being about 35. It's like 34.6. So in this case, we see that the block will be moving down the ramp. Oops. Down the ramp. And the reason being is because gravity is going to beat that applied force. So right off the bat, if we look at the option, it's not going to go up the ramp, which is nice. And more importantly, we know that friction is going to oppose motion. So you're going to have a force due to friction right there. Okay. Now we can utilize Newton's second law. And we'll just do the sum of forces in the x direction is mass times acceleration in the x direction, where the acceleration is what we're ultimately looking for. So we have a force applied, so we'll call that F, plus a force of friction minus the component of gravity in the x direction times this. And we know that the force of friction is the normal times your kinetic friction We know that, oops, sorry about that, scrolled off. We know that this component is mg sine theta by just right triangle trig. I'm going to leave off the arrow at this point. Now, what is the normal force? We know this, we know this, we know this, and we know this. We have one equation with two unknowns. We're going to want to consider the y component of Newton's second law, which is going to be equal to 0. The block's not bouncing up and down the ramp. So then the normal force is equal to mg cosine theta. So now that we have that, we can plug that in for our normal, and you get F plus mg mu kinetic cosine theta minus mg sine theta. It's all divided by m is equal to our acceleration. And we have all this stuff. So the applied force is 10. So we have 10 plus 5 times 9.81 times 0.5. Cosine of 45 is root 2 over 2 minus 5 times 9.81. Sine will be the same thing. All over 5. Yeah, so you just plug this stuff in, and once you get all of that, you should end up getting, I think I plugged in my other calculator, but I believe it was root 2b. I think that's what that ends up being. So yeah, that's all there is to it. Free body diagram, determine if it's moving up or down, and Newton's laws. So that was the first problem, and I'll try